This is section 3.5, Ratios and Proportions. A ratio just compares two amounts. It can be written in several ways. It can be written in words like A to B. It can be written with a colon, A colon B, or it can be written as a fraction, A divided by B, or A over B. But regardless of how it's written, it's read the ratio of A to B. Now, ratios always have to be in the simplest form, so you have to reduce them. You can't leave it like 50 to 25. You have to reduce that, all right? So it's just like a fraction in the simplest terms. So in the first example, we're going to write a ratio, and here's the problem. Suppose a team plays 14 home games and 10 away games. Write a ratio of home games to away games. So when they say of something, that's what goes first. That's what's going to go in the numerator if you're making this a fraction. The to part is what goes into the denominator, or goes second if you're writing it with a colon. So to write a ratio of home games to away games, we're going to put the home games, 14, over the away games, 10. But unfortunately, this isn't reduced, so you have to reduce this to 7 to 5. And that's how it's read. 7 over 5 is 7 to 5. If you needed to write a ratio of home games to all games, you have to add the home games and away games to get all the games. That would be 24. So you're going to put 14, which is the home games, over the 24, which is all the games. And again, you would reduce it, so it's 7 to 12. Let's write some more ratios. Okay, let's think about cooking or baking. You're making chocolate chip cookies, and you're using 7.5 cups of dry ingredients and 2.5 cups of wet ingredients. Write a ratio of dry ingredients to wet ingredients. The ratio would be the amount that they list first. The of amount goes in the numerator, the dry ingredients, which is 7.5. And then the wet ingredients is 2.5 cups, so it goes in the denominator. So it looks like this, 7.5 over 2.5, or 7.5 to 2.5. But we don't use decimals and fractions, so you have to reduce this to remove the decimals. Okay? 7.5 is divisible by 2.5, and that is 3. And 2.5 divided by 2.5 is 1. So the ratio is actually 3 to 1. What if you need to write the ratio of dry ingredients to all ingredients? Well, again, because you're listing dry ingredients first, they go in the numerator. That's 7.5. And all the ingredients are the wet and dry together. So it's 7.5 plus 2.5. That's your denominator. It's 10. But we have to reduce that again. I divided the numerator and denominator by 2.5 to get 3 over 4. Or 3 to 4. That's the ratio of dry to all ingredients. But what if your numbers don't work out that well? If you end up with something like 6.5 to 2, you can't leave that as a fraction. You could reduce it, right? You could reduce it, and then I would change the form. So they both have a 2 in common. You can bring that down to 3.25 over 1. But we never leave decimals and fractions, so you wouldn't write the ratio like a fraction. You would write it with a colon, or you would write it with a 2 between the two words. That is 3.25 to 1. Proportions are two ratios that are equal to each other. So it's an equation that states that they're equivalent. You'll have one ratio on one side of the equal sign, and one ratio on the other side of the equal sign. So it looks like something like this with the letters A over B equals C over D. And here, of course, B and D cannot equal 0 because we can't divide by 0. If you don't know the value of one of the variables here, but you know the other three, you can actually solve a proportion by cross-multiplying to solve for the missing variable. For example, if I have two ratios that are equal to each other, 11 over 6 equals x over 30, we only have one variable that we don't know the value for. We know the values for the other three numbers. So we can solve for x by cross-multiplying. So you would multiply 11 times 30 and set it equal to 6 times x. That is 333 equals 6x, or 55 equals x when I divide it by 6. I'm sorry, or 55 equals x. Let's just get rid of that. There, that was corrected. I don't know what happened with my typing there. In that last step, all we wanted to do was switch around so that the variable was on the left-hand side and the number was on the right. So it should be that 55 equals x, or x equals 55. Now, this system works whenever you just have one term on each side. So when you have a one ratio on one side and one on the other, then you can cross multiply to solve for the variable. Let's take a look at a couple more examples. In number 2, we now have the variable in the denominator. We have 2 over x equals 8 over 40. To solve for x, we're going to cross multiply. 2 times 40 is 80, and x times 8 is 8x. To solve for x, you divide by 8. So x equals 10. So 2 over 10 equals 8 over 40. That's what we're saying when we solve for that variable. In number 3, it gets a little more complicated, but you can do this. You just have to use the distributive property. In the numerator, we have 3 plus x. In the denominator, 10, and that's equal to 6 over 5. To solve for x, you have to cross multiply, but now we're using the distributive property. So it's 5 times the quantity, 3 plus x, equals 6 times 10, or 60. 5 times the quantity, 3 plus x, is 15 plus 5x. Set that equal to 60. Then subtract 15 from both sides to give 5x equals 45. When you divide by 5, you get x equals 9. You may have even more variables on both sides of the equation, but the method is always the same. When you have two ratios set equal to each other in a proportion, you always, always, always cross multiply to solve. Here's a word problem. A recipe for salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed to make 4 pints of salsa? There are a couple ways you can write this proportion. It just depends how you think. In the A version, you can write the ratios that express tomatoes to pints for each size. So you can see in the first fraction we need 30 tomatoes in the numerator, 2, so in the denominator, 12 pints of salsa, and that equals X number of tomatoes, we don't know how many, to 4 pints of salsa. So we're writing tomatoes, 2 pints. To solve it, you would cross multiply. But maybe you don't think that way. Maybe you think like the guy in B. You could write the ratios that compare the tomatoes in the small recipe to the tomatoes in the large recipe and set that equal to the salsa from the small recipe to the salsa in the large recipe. So it could be X, the ones you don't know, the tomatoes in the small recipe, to 30 tomatoes in the large recipe, and that would equal 4 pints of salsa in the small recipe to 12 pints in the large recipe. You just have to make sure your numerator and denominator match, and your numerators across the equal sign match. So if you're doing tomatoes to salsa pints, you better have tomatoes in the numerator of both those fractions and pints in the denominator of both those fractions. And then you would cross multiply to solve them. In both cases, you're going to get x equals 10. It doesn't matter how you set it up, so do it in a way that's most logical to you. And now let's take a look at the elevator problem. The elevator in the John Hancock Center travels 150 feet in 5 seconds. The observation level is located on the 94th floor, 1,029 feet above the ground. Find the time it takes the elevator to travel from the lobby to the observation level. So how we're going to solve this is write a proportion. We're going to set x equal to the time it takes to travel to the 94th floor, because that's what we're trying to find. So if we know in the first ratio that it takes 5 seconds to travel 150 feet, so we write 5 in the numerator to 150 feet, And we're going to set that equal to X amount of time, I don't know how much, over 1,029 feet. Okay, you can see in both ratios we have the time in the numerator and we have the distance in the denominator. Okay, that has to be the same in both ratios for the proportion to work. To solve this, you're going to cross multiply. So we take 1,029 times 5 and set that equal to 150 times x. 1,029 times 5 is 5,145, and that's equal to 150x. When you divide both sides by 150, you get 34.3. Okay, now remember what x was, and that's why it's really a good idea to always define your variable at the beginning of the problem. X was the time it takes to travel to the 94th floor, so we found that it took 34.3 seconds to travel to the 94th floor. Writing ratios and proportions is not difficult. It actually is very logical, and it's a great way to solve word problems, especially when you're dealing with two different situations, one you know and one you don't quite know. You'll see recipes a lot, you'll see schedules and games a lot, and you'll see distance and time a lot. So get used to doing those kind of problems.